Comms check. Hey, Dan joined.
Hey, Dan.
Just had to wrestle with Zoom crashing in Chrome. This has been fun, but it's back. Okay, who do we have? While I bring up some slides here, so welcome to the August call. I need to set up another one for this month because I think our calendar invite has run out. But first, the quick ground rules. This is this you notified this is being recorded, but this is an open source call to supplement community discussions about any topics that we would otherwise talk on the mailing list, but can have a more high bandwidth discussion on the call. Now, I saw that there were some uh, additions to the agenda. Let me pull it up.
Is Dan Middleton going to join as well?
He usually joins, but if he's not here by now, maybe not today.
Yeah, Dan, I added something on hot loading TDX module and SMP firmware, but that can go after your agenda.
Okay. I mean, yeah, we can make it a freewheeling discussion. So let me let me bring that up because I'll try to manage the time. Maybe we can do that first. But yeah, so we did the ground rules. But before I jump into any of the topics, is there anybody new to the call that would like to take a moment to introduce themselves and their relationship to wanting to discuss secure devices and computational computing? Looking down the list here.
Hi, this is Steve Smalley. I'm with NSA's research group, and we have a body of research and development in the confidential computing space, as well as a lot of past history in SE Linux and Android.
Okay. Welcome to the call.
Hi.
Well, actually, yeah. So Deanna's doing it right, and so use the raise hand option here. Since we have a few people, I'll call you in the order I see you on the raise hand. So, Deanna.
Yes, we had a meeting with TDX team at Intel yesterday, and
Is this open source information?
Yes.
Okay.
They wanted to bring the conversation about migration and firmware updates, live firmware updates to the CCC for what is the acceptable semantics, whether the guest has to accept a firmware update slash TDX module update, or if the host is allowed to do updates without consent. I think
this overlaps pretty well with Peter's topic too, right, Peter?
Yeah, that's my agenda item.
Okay. So yeah, doubly noted. We will get to that. Anything else to add to that? To the opens?
I just didn't have the agenda open in front of me.
Oh, sorry. Yeah. Actually, so Steve Rutherford took the initiative to create the running meeting notes, and so yeah, we'll post those in the chat, or somebody can post it in the chat. And going forward, we can collaborate on the agenda items in that document ahead of time. But yeah, I should flip to the agenda on that. But let's continue with introductions. So next up, I have Kleber.
Hi, hello everyone. My name is Kleber Souza. Work at Canonical. One of the managers at the Canonical Kernel team, and I'm getting involved in some discussions with our partners for supporting various computational computing technologies into our kernels. So yeah, nice to meet you all.
Yeah, good to meet you. Thanks. Welcome to the call. Next up, I have Sagi.
Hi, I'm also working with Dion and Peter on firmware hot loading for TDX.
The hot loading hot topic. Okay, you're welcome. Pratik.
Hi. So I work at AMD, and I look at secure encrypted virtualization and secure nested paging, that sort of stuff.
On the kernel side.
Yes, yeah,
Okay.
on the operating, yeah, and then the next kernel side. Yeah.
Okay, and then Catherine.
Hey, I'm Catherine Zen from Google. I work with the Googlers here on the call. This is my first time joining. I'm also part of the CCC tag representing Google. So my part of my mission this year is to help with various upstreaming effort. So that's why I'm joining this call. It sounds like we have a very good representation from Google. So I think we are covered pretty well from Google side. So I may not join every call in the future, but nice meeting you all.
Yeah, thank you for that, and welcome. And yes, good to see a healthy representation from Google here.
Thank you.
Anybody else that is new that wants to give a quick announcement, introduction?
Hi, Erdem Aktaşkir, also from Google. I'm with TLM, work on the enabling TDX team. So, hi to everyone.
Hi. Yeah, welcome.
Hi, this is Vishal. I'm also working at Google on enabling TDX VMs with Ardham and Sagi and other folks. Thanks.
Perfect. Okay. Last call for that. I'm not seeing any other hands raised. Okay. Yeah, let's spend some time talking about hot loading of TCP components. Peter, you put the agenda item in the list. Do you want to introduce the topic?
Sure. Thanks, Dan. Yeah, so we've been working with AMD and Intel on this. Our biggest concern is basically being able to patch vulnerable TCP components to meet embargo deadlines. So hot loading makes that a lot easier for us. I think, as I assume most people here are aware, we had a couple S&P CVEs that went public, a long time ago, not breaking embargo here. So it would be a lot easier for us to, without disrupting VMs, to upgrade these live. So that's what we're working on. So we know that the AMD hardware has this functionality through the download firmware command. TDX also has this functionality through TD persist, I think it's called. So yeah, I think the big thing that we heard from Intel during non-NDA call was they had some pushback that guests might not like their TCB to be upgraded while running. So we wanted to talk about that here and see if anyone does actually have this concern. I think internally we were a bit skeptical about this concern since your TCB is only going to increase and therefore hopefully security as well. So yeah.
I would rephrase the concern here. The concern here is about the ability for kind of generic upstream components to coordinate this update policy, because really what the concern is basically compliance versus security, in the sense that, like, the moment any one of these updatable components regresses security, where it says, oh, the security version number increased, so it should be more secure, quote unquote, should be. Like the moment one of those doesn't, and we can imagine that it might happen. Like we might be like, oh, version 1 has an issue. Version 2, oh wait, no, we need version 3. Like that's going to happen. What does that? What is the guarantee being made to the guests? So because you can imagine two kinds of guests. You can imagine the fire and forget guest, which just says, I don't care if there's a CVE underneath me, change it, and I'll figure out later what to do about it. Like immediate, please, yeah, update aggressively to keep me compliant. And there's going to be another problem, maybe a smaller set of users like, do not change my TCB without me being able to have a say about it. I want to I the tenant need to have this control, and I need it because I want to say no to updates if because I tested one TCB, and maybe I'm not signed up to this understanding that if this SBN number goes up, then the security is only getting better.
I understood. I think, is this the right place to establish that contract, or is the CSP customer relation the better interface there? Because, we can build this functionality not upstream and do this, but that's not the right thing to do. So we'd like to build that upstream, and we would also like to give our customers, those options, a variety of options depending on their preference. But is this hypervisor guest interface really the right place to be doing this?
I mean, I think that's the rub. Like, what this is really, I mean, that decision between compliance and security is really kind of a, to me, is a contract decision between the tenant and provider, not really the system, like the upstream generic components. So so it comes to me like as a hypothetical question, like who should how do who deploys this policy, and how do we maintain it, in the sense that how do we describe to people describe to upstream to say this update, depending on what your tenant policy may surprise you. Like it's hard to see how upstream can make a decision about that, which something really comes down to a CSP tenant relationship. I see Erdem's hand straight. Oh, actually, let me see. Let me get the people in order. Diona had her hand raised first.
I was just going to suggest that this is very much a business contract decision, where customers could say, I want to make sure that I'm running on a pool of machines that will be on a specific version for at least 6 months, whatever. But the confidential computing technology should be set up to not trust the host at all, for whatever it's allowed to do. So I'm just there's lots of firmware hot loading that is also in the TCP that is also allowed. I'm not sure why some pieces of firmware would be subject to this no hot loading requirement.
It's a question of, how do you communicate that, oh, by the way, the world has changed underneath you, in a way that's common, that everybody can understand. Like on the device firmware update side, we can replug the device, we can re-authenticate the device, we can say, hey, we're about to do a firmware update, drop the TDI for a bit, let it come back, do the full reattestation, keep it going again. It's almost a migration to change the TCP. Let me go to Erdem.
So I think Jenna covered most of the things that I was going to say, but I was going to say that again, by design, right? We don't want computational computing any resource, right? Still managed by the host, right? And we don't want one confidential computing instance to control what's going to happen on that host security, like overall. Like, so I can understand that customer, let's say, do an attestation and say like, hey, I accepted, let's say, TDX 1.0, and now that's the grant that I want, right? But then, as Diana said, it doesn't stop hosts to do ucode patching. Right? So the SVN number might be still bumping up. That guest is not aware of it today. And it might be also needed, right? Because there might some critical patch is there and we might need to update. So of course, customer can say that if you're going to do it, just terminate me. This kind of options can be given. Maybe that might be the one that we might need to ask customer, like, hey, if something is going to happen, then what you want to do? You want us to terminate you or just notify you, right? So that you know something has changed. But I think the worst options will be like preventing that to happen, right? Because again, maybe something's like really critical and we have to update. And that's already happening, right? The ucode patch is already there, where we can update it without the confidential instance knowing it. Then if it's already happening, then in this case, we shouldn't do anything less than that and saying like, hey, you cannot really upgrade the TDX module. That doesn't seem right to me from, again, a philosophical way. And what we can do about it, as I said, we can give the customer two options, either notification so that they can log it, something has changed, or they can choose to, like, if that happens, I don't want it, just terminate me. Does it make sense what I'm trying to say here?
What you're saying makes sense. It's that last mile piece about the notification mechanism and who maintains that and who publishes that. Like that how I as a tenant subscribe to that policy seems like a CSP infrastructure specific piece of code,
I think
right?
it should be a passive way, right? Because if it becomes active, it will become complicated. What I mean is notification is first at the time of instance creations, we can expose through the attestation report, right? What are, like, we can just say like, hey, this TD is accepting any SPN upgrade, right? Then customer through the attestation, if they don't agree with that setup, they can choose to not to load anything critical, right? And the second thing is notification might be just as simple as like an interrupt injection, so that guests know that they can do it TD info and then get the latest version again and log it somewhere. So we can offload that kind of decision to the guest and or implementation to the guest itself and keep the other part minimum, right? When say other part, the change in the TDX module or in the host. But what I'm saying, at least if we agree that we should allow hot loading, then the rest is a different discussion we can discuss. But I thought the first question was like, there was a little disagreement whether we should allow it or not. Right?
Yeah, I think it's less about allowing it or not, and more about how do the common upstream components support this use case, and how do we describe because I think where the upstream discussion gets off the rails is when you get to the point where you say, okay, I have tenant A that's a compliance tenant that says update me aggressively and tell me about it later maybe, and then we also have on the same host tenant B who's like, do not surprise me, my TCB is my TCB, I don't even care about SVN updates, like I do not want to have surprises. Those How do we square those competing concerns in the common code? Like how much of it, like how much of the is this solution something that should be upstreamed or something that has by definition has to be CSP specific because CSP is going to own that business contract?
Dan, it sounds like you're asking for a feature of TDX and S&P because right now there's no architectural way for us to guarantee these change like that we know, like we can establish a contract with the guest, but we could break that contract unless there's something in these architectures, right?
What do you mean? Like the guest like has to trust the CSP to not
Well,
to honor the TCB. But go ahead.
it sounds like you're saying that we should notify the guests of TCB changes as the CSP, which I agree with, but that contract could be broken maliciously. If there were a feature as in part of TDX or SMP or CCA to notify the guests somehow or change change their measurement distinctly, I don't want to design that here. Is that really what you're asking for? So that this cannot be broken, the contract?
No, I'm asking the question, just how do we build this solution, like you say, like allow hot loading when we know about cases where tenants are going to disagree? Who's
So
responsible for resolving that conflict?
And I'm not sure whether notifying guests even makes sense here, right? It may be too late. Is the moment you update TCB has access to almost all the keys for the SPDM and also DSM side of things. So the tenant has to either pre-authorize or block it.
Right.
Can I ask one thing here, like just to clarify that? So if at the time of TD creation, right, and we notified it as part of the TD report, if the guest knows that whatever the version that we are reporting, either SVN or TDX module, is the minimum, and seamless upgrade is enabled, like part of TDX report, and then now the guest has a chance to either trust this or say like, it is not what I want, right? And they can choose not to run any TD. So isn't that enough disclosure and giving the guest to make a decision based on they accept seamless upgrade or not?
I mean, only if you told me that every tenant that's going to launch is subscribing to the minimum SVN regime versus the never change it regime. Like,
I mean, there's not even subscription. What I mean is like the report says like, hey, you are running TDX 1.0 and seamless upgrade is enabled, which means at any point we might upgrade it, right? And at any rate, each customer needs to look at the attestation report and decide whether they trust or not, right? So then,
I think that I'm not sure that that's there today, but I mean, I think that helps the situation if the report can tell you upgrade is enabled or not enabled, so you can say like, hey, yeah, I can at the beginning of time say I never want to be upgraded, because I think the hard part is we don't want to build a notification mechanism. That's just really, it gets really complicated. We really want to say we are either in the compliance world at boot and you opted into this please update me world, and in other cases you are guaranteed to be on a host that's never going to do that. But I don't think that's in the report to tell you that you might be upgraded.
Today it's not that, but if we ask Intel, for example, include if seamless upgrade is enabled or disabled, right? Then first it will make the life very simple, right? In terms of like, hey, the guest can choose if seamless upgrade has been enabled or disabled on the host and decide to trust or not trust. And today CSPs can build mechanism, either support one of them or both of them, right? Because either at the time of VM creation, we can ask customer, hey, do you agree or not? Or we can even not give that option only and give only one option and say like, hey, this is what we provide. And if you are comfortable with that level of security, then you can run our system, right?
Yeah.
If that is okay, then that's something we can ask Intel, because that should be a simple change, rather than subscription mechanism that each TD says like, hey, I allow, I don't allow, and then TDX module just keep tracking. I believe that's very complicated.
That's very complicated, yeah, and I mean that's really where the things goes up.
Then I believe just including this information in the report will solve the issue. The notification, I still believe, needs to be there, not as a security guarantee, but just like
ease of use, kind of.
Yeah, it's just gonna tell the guest itself that something has changed, and again give the response to the guest whether they want to update their report and or just log it somewhere, right? Just in case if some behavior changed, that they will know which version, which software stack that they were working on it, right? So but they're independent, so they don't have to be at the same time. We can ask them as a separate, or we can discuss them as separate entities.
But what I want, what I want to do now is, since we have other host vendors on the call, is talk about like should this be a general Linux requirement that says Linux policy is that if you want Linux support, your host's implementation needs to enumerate whether upgrade is enabled or not. Is that something that like all host vendors can sign up to?
I think, and sorry, I talked too much, so I'm going to do not talk. I think I would prefer the simplest one, just like if we can expose to the guest if SIMS upgrade is enabled or disabled, and then TDX module of course needs to check that if there's any TD started with SIMS upgrade not supported, right? So that's a TDX module requirement. But kernel changes should be like very simple. It should just have the TDX seamless update capability, and TDX module can reject if one of the TD has not started with seamless upgrade enabled, right?
Yeah.
That's what I think.
Let me go.
That
makes sense. Let me go to Diona.
Yeah, yes, Diona. Sorry.
I think I'm just gonna pull. I don't think that this is the kernel's philosophy to decide policy about how hardware is supposed to be used. So if this is something that hardware needs to do to prevent hot loading, etc., that needs to be explicitly in the hardware, and then the kernel just gives access to those features.
Right. I mean, like, but that's the benefit, I think, of enumeration, where the kernel doesn't need to get involved, because the kernel knows, like, hey, this thing you're testing to is told to you, like, you've signed up for this, not and the kernel basically this enumeration would take it out of the kernel's hands, versus like the kernel having to figure out like what is the kernel's responsibility, what is Linux's responsibility to enforce this TCB, whether conservatively or not.
I hear a keyboard again.
Yeah, I hear a keyboard again. I think it might be heard him maybe. But
yeah, I was typing. Sorry.
Oh no worries. But I'd like to get reaction outside of the TDX use case from, like, is this, don't want to put anybody on the spot, but like
SFS&P want to allow seamless upgrade because it's just part of the hardware.
But I mean, but it's the same problem, right? Like you were talking to one SMP ASP firmware in one instance, and the next instance you're talking to another.
That is the capability of the technology. So until the technology adds, say, another platform info bit and guest policy bit to negotiate that, that's what you get.
I see Michelle's hand raised.
Yeah, so now there are a few scenarios I would like to point out here. That one, CSPs might choose to give certain promises around maintenance experience to the VMs, which means they could say that VMs will not go through certain maintenance for certain days, duration of days. When we give choice, so that is one point. The second point is there could be security issues in TDX module or other components that could allow guests to exploit or attack hosts and CSPs framework. So that becomes very important for CSP to roll out at priority. So giving a choice to guests, there is a bit of conflict if we allow guests to decide that they want to opt out of seamless upgrade, which means that they would have to compromise on the maintenance experience as well. But yeah, just ensuring that this is also considered in the discussion.
Yeah.
So just the point here is that the TDX model, I mean, the upgrades would be necessary and could be necessary and would be needed to be done in a certain duration of time based on the severities. And seamless upgrade is the best way for us to achieve that without disrupting customer workloads. So at certain point of time, that probably should take precedence over other factors.
Yeah, I don't think anybody is debating the value of being able to do hot updates like that. That's not the issue. But um, but yeah, I think we had a good discussion about this. Let's. I think we need to take this to the list. I think if we had this policy option, or if the kernel could point to and say, "Hey, this is enumerated to you," and so if you are one of these, it's probably the minority, but it's not. It's probably a non-zero number of deployments that care about the opposite problem of knowing exactly when the TCP changes, even if it's just an SPN upgrade. As long as they're not surprised, then the kernel doesn't need to get in the way. But then that kind of opens the question of we don't have any to the point of we don't have any enumeration of the fact that that microcode is dynamically updatable underneath you within a certain SPN range. But is it safe to assume that the reason that no other host vendors are speaking up is because they don't have to coordinate their updates through any in any of these policy concerns about surprising running guests? Like every other host vendor is just like, yeah, we're just going to surprise guests. And that's it. Because yeah, I think as long as it's like this is how this works. Everybody surprises guests. Guests need to understand that it's just hard to reconcile the fact that we're spending so much time to validate the launch state, validate the topology, validate the attestation, validate everything, and then the things change off underneath you.
I guess, Dan, we're only changing things in the way that the hardware vendors allow. So I don't have so much like am I not having enough concern? Like, shouldn't Intel and AMD only be providing us with yet better TDX modules, etc.? So
Oh yeah.
Yeah.
But like the old saying goes, stuff happens.
Agreed.
And so it's the question of how it yeah. Are you deciding? Is everybody just going to sign up for the stuff happens case? But yeah, let's let the enumeration of upgradability percolate and try to have this discussion on the list to move it forward. Any other comments on the? Yeah, but thank you for the topic, Peter. I think it's an important issue, and it really gets to this debate about compliance versus security.
Thanks for the time and meeting, Dan.
How we do it. So the other thing I wanted to highlight in this call was some pending patch sets that are on the list. Two of them so one is I'm calling it the private memory discard manager. The patch that's actually called shared device support. The link to the patch set is in the meeting notes, and as part of that discussion, I was catching up on it. Like one of the debates there is discard managers are for unplugging memory typically, and with confidential computing, reusing the discard manager for private memory, the shared to private conversion, uh, generates this conflict of like, yes, the memory has left the shared domain, but hasn't left the VM. And so how do we maintain the ability to hot plug memory, have VFIO mem and these other solutions, while also being able to do page conversions between the two domains. So Dave Hildebrand got in on that discussion, and to me, there still seems to be this assumption we have to work through, where people say, "Oh, it doesn't really matter about managing this for devices because devices will either be private or shared, and when they're private, then the IOMMU is managed by the secure domain, so we really don't have to worry about this." But I think the education campaign that's ongoing is that devices are going to pop in and out of secure world due to errors or setup time issues and these kind of things. And so the ability to be able to operate a device fully in shared mode with DMA bounce buffering and at one point in time, and then being able to operate it as a private device at another point in time is going to be part of having competent error handling. And so, but so check out the discussion. I think one of the useful things in there was this patch from Google called exclusive gut pinning that David pointed to, and this was discussed on the MM call, and how it intersects with private memory, computational computing, and large pages and these kind of things. So I do think this patch that moves the ball forward in the sense of it making shared device assignment not break, but it does come with these caveats about, hey, you got to give up memory hot plug, and hey, you got to map everything as 4K until we can figure out large pages better for computational computing. So this is also this. But I also wanted to highlight this because it's an example of a piece of infrastructure that we all need, we industry need, and I think we also are experiencing the scenario that upstream has a limited amount of ingest speed for patches, and we're starting to build up a decent backlog of things that are outside or that are in that queue, and so I feel like we're at a point where we need to better coordinate these kind of really common pieces, but put them in a place that they can be staged and everybody can test them, as preparation for going into the maintainer review queue and the upstream trees. So I want to have this was actually something I wanted to talk about at Plumbers. I'm gonna see if I can arrange a BOF to talk about how we can coordinate this better. But I think this for me, this patch set is kind of that proof point of like, hey, yeah, maybe we should have a place where we can stage, where the industry can stage their TIO stuff, while waiting for QEMU and kernel communities to ingest it. So stay tuned for that at Plumbers. I don't know if anybody has taken a look at this patch and has any opinions on this problem of memory hot plug versus like guest memory hot plug versus page conversion, and how does QEMU handle that? Vishal, I see your hand raised.
Hi, Dan. Yeah, so we at Google are interested in, and along with PKVM folks, are interested in driving this conversation ahead. Um, my plan is to also discuss large page support at LPC uh, for guest MMFD, which yeah, I think we have a topic set out in KVM micro conference. There, this topic will slightly come up, but to your point, uh, I would say that yes, I mean we have been trying to discuss the large page support since pretty long, probably a year or so. So I completely agree that has to be some way to get that discussions and priority. Oh, yeah, hopefully this forum solves this problem. Regarding maintaining this effort or staging this effort, um, I believe as of now it's part of KVM subsystem. Most of this effort that is falling in, and they do have certain staging branches for certain efforts, but I'm not sure if that's what you were referring to when we are talking about staging.
Well, I mean, I think there's KVM staging and there's QEMU staging, and then there's TDX staging and SMP staging and the ARM thing and the RISC-V thing. It's like, do we need a unified kind of uh, staging to say like this version of QEMU with these PKVM staging branches, this is the kind of the industry snapshot of like this. I'm calling it TIO next. Like this is the place where um, because I think there's a lot of people that are watching. I think that are watching the space that want to try it out. They want to put all the pieces together, and there's pieces all over the place. And uh, uh, I think going to each hardware vendor individually and asking like, what's your QMU? What's your view of the staging is kind of counterproductive. If we can also if like it would be lovely if we said, hey, this combination of QEMU uh, and KVM staging had this regression that affects everybody. Vendor A fixed it, vendor B benefited from it, and off we go to the next. And then when we finally go upstream, we say, hey, maintainer, like these vendors have been chewing on this, and it's working for us versus like trying to corral the cats of every vendor for themselves, kind of thing. That's where I'm kind of getting at the staging piece of it.
Makes sense. So basically, how my point here would be then, I understand that there is a lot of information, a lot of scattered pieces of work that is going on in different components. Yeah, I agree that it would be great to have this collated somewhere in under one topic somehow, so that everybody understands what's going on there. But yeah, I do not have good thoughts here. I mean,
No worries.
good options that I can suggest.
For me, for the purpose of this call, it's enough to just kind of get the idea out there and have somebody else nod their head, say, oh, that sounds like a nice pony to wish for. um, um, could you point me to the like maybe in the chat or in the meeting notes the staging branches for some of these guest MFD changes? Maybe they're linked in that patch set I was, but
Yeah,
it'd be good to capture those in the notes at least.
Makes sense. I'll add them to the notes later. Yeah.
Okay, thank you so much. Okay, moving on. So the other patch that's on the list that I think want to get more attention to, and I don't think we've gotten the review feedback on some of the like it's gotten review feedback. This is the patch set from Lucas on supporting native device authentication via PCI CMA. The reason that's relevant for the TIO side is that patch set proposes some sysfs ABIs for communicating device certificates, measurements, transcripts a bunch of ABI details that we're going to need anyway in some form or another for TIO device attestation, and um, and the review comments so far haven't touched the suitability of that ABI yet. And so, Lucas, if you want to say more, you're free to. But I think that's the place where we're kind of looking for use cases, community feedback on that ABI.
Right. So I just pasted a link to that patch set in the chat. So please have a look, and you can either. So if you have SPDM, CMA SPDM capable hardware, you can test it with that. I know that Alexei from AMD has begun testing with some AMD hardware and hit some issues which have been discussed in that thread. And if you do not have capable hardware, you can test it with QEMU. There is a link in the cover letter to a guide how to set up QEMU for testing CMA SPDM. And what I've added in this version 2 of the patch set is that I am exposing a log in SysFS whenever a signature is received from a device. That is a feature that was requested at last year's Plumbers conference, and I would be interested in hearing feedback whether the chosen SysFS ABI meets the requirements of people who are interested in that, or if I need to change anything, if I need to add anything. So yeah. So the idea is basically that if you do not trust the kernel to verify the signature received from the device, you can go to SysFS and see the signature there, and you can re-verify the signature. All the necessary material to re-verify the signature is available. And there is also an example in the documentation how to re-verify with OpenSSL. So it's really simple. It's just a few commands. And people wanted that for remote attestation services so that they can check if they do not trust the kernel to do everything correctly. So they want to check if they basically, I think the idea is to send that data to a remote attestation service, and then that service can decide whether it's fine, the signature is trustworthy or not. So please go look at that patch set, and I'm looking forward to your feedback on the mailing list. Thank you.
So thanks for that, Lucas. And when we get to QEMU and use case and debate, like one of the feedbacks, and Lucas and I have gone back and forth on it, and I admit that my concern is only theoretical, but I think this is also where practical use case feedback can help, is around the Linux policy around what to do with PCI CMA by default. When we get to TIO, then we'll have the option at that point to select between, hey, do you want to validate device certificates natively, or do you want to ask the platform solution, TDX, SMP, Cove, to do that for you. The concern for me right now is that by default the authentication is done mandatorily and automatically every time, which what we don't know is how the industry plans to deploy the capability. To me, I think there's quite a few use cases that people have planned for. Well, one of the current use cases for the SPDM authentication core is really like that has a near-term user is NVMe, but that use case is more dynamic. It happens after the device is loaded, and sometime later. It doesn't automatically happen at device discovery time. But that use case is more for like secure inventory. Like, hey, did I install all the drives with the serial numbers with the firmware versions I expect, and can I validate it in a cryptographically secure way? But when we get to the point where you have a choice between authentication providers, I'm not sure that we want native to by default do this authentication work. I think it might need to be optional going forward. But we can always, it's something we can change once we have the use case in hand. But I think that's also the reason for calling for more people to review it, is like let's start talking about practical use cases that people want to deploy, and what optionality they need in native CMA policy.
Right. I mean, if you know it in advance that you're not interested in any native CMA applications, maybe you're deploying this on a server in the cloud on a host, and you just want to delegate all the CMA SPDM handling to the TDX module or whatever. And if you know that in advance, then you may want to disable native CMA in the kernel and let the platform do all that. So in that case, I agree. Maybe we need a command line option or a syscontrol option or something like that to disable native CMA. But yeah, as you say, I'm fuzzy what the use cases will be, and the only downside, or there are two downsides. One is that there is a delay of a couple hundred milliseconds to authenticate every device if native CMA SPDM is enabled. And also the VM Linux text size increases slightly by a few thousand kbytes, because you need to have the CMA SPDM code built in. It cannot be a module. So these are the two downsides that you have. I don't know if that justifies having an option to disable native CMA SPDM. I mean, yeah, so that's up for further discussion on the mailing list.
Yeah, but I think we have nothing but time to figure that out. I do see your comment in the chat, Diona, about measure the policy and make it configurable, default, fail, secure. What do you mean by measure the policy?
Whatever you want to do in terms of like, oh, I don't even have access to an authentication server. Should I fail secure and just not allow the device, or should I fail safe and allow it? That seems to be a policy decision on the VM deployer's side. But I'm also thinking that since we need to implement early attestation in SVSM, that kind of policy decision can just be left to a trusted service, if we want to account for that too.
Yeah, that's my feeling. That operating devices in an untrusted manner is going to be the norm, and at some point, because you might need to operate it in advance of saying, okay, now I've measured everything, I've looked at everything, I want to convert this device to private, I want to make sure this other device is not there, and then you say, okay, now convert everything to the kind of the private state and start deploying secrets. So it's, yeah, I don't think it's like right. Like I don't think just because we have CMA and we have the ability to authenticate devices that means that everything that's not authenticated is automatically malicious now. It's just a state of the device that you can use to make a decision about the security posture of your VM, but it's not the case that like the kernel should be assuming that every unauthenticated device is malicious. That's the deployment policy decision to make about when they go to attest the entire device or TD state.
So if you look beyond the VM use case, for example, I could imagine that on notebooks, Chromebooks, people might be interested in using CMA SPDM to check whether a hot-plugged external device, let's say a Thunderbolt attached PCI device, is trustworthy or not. And so maybe in those cases, basically the forced authentication that I'm performing in my patch set on PCI enumeration, that is one of the ideas is that we may have use cases like Thunderbolt where you want to always authenticate a hot plugged device and check whether it is an authentic device. I mean, the idea is really that if that device is truly malicious, I'm just concerned that that device may spoof TLPs and send those spoofed TLPs up to the root complex of the CPU, or it might laterally attack other devices via peer-to-peer DMA. So I'm thinking that if we determine on boot, okay, this device cannot be authenticated, let's just fall back to the safe mode and firewall it off. Let's just disable the PCIe link to that device. That could be one option of how we could react to an device which fails authentication. These are just ideas, and I just want to keep the option open to support such use cases. That's one of the reasons why I put this in the PCI enumeration code path.
Yeah, I think, but part of the other concern about the attack vectors you talk about, some of those cannot be closed are not addressed by CMA. That's what IDE is for, and sending T equals 1 traffic and all that implies, because all CMA does is tell you that you talk to an SPDM agent somewhere that matches this other device ID you read somewhere else. But in terms of like when you're actually talking to the device and sending MMIO, you have no idea whether you're talking to that same device or not. But yeah. So take a look at that, folks on the call. That is out there. We reached the top of the hour. I really appreciate all the engagement. Yeah, please do continue to put agenda items in the notes, and I will schedule another call. Try to make it. We'll still keep doing the China friendly, Europe friendly kind of trade off, and I will see you all at the next one. Thank you so much.
Thank you, Dan.
Thank you, Dan and folks.
Thanks, Dan.
Thank you very much. Goodbye.
Thank you.